Okay, so we have to see if this is an identity. Best to simplify from both sides for this one. So left side, 1 minus cosine squared x. Let's change this into 1 minus sine squared x over cosine squared x. And our goal is to express it as one fraction perhaps. Right? So this will become a cosine squared x minus sine squared x all over cosine squared x. Okay. So this does equal to this. Okay. So we have 1 minus sine squared x using the Pythagorean identity. Now in the numerator we have this. Okay. Let's expand to see if we can get this on the top. So you get okay. Alright, so let's see if there's anything here we can collect. If there isn't anything we can collect, let's take a look at the right side. And the right side only has sine. Alright, so that means we should try to convert everything into sine. So this should be 1 minus sine squared x. Okay, this one stays the same. Okay, and this we can replace it with 1 minus sine squared x. But that's just cosine of squared x. We need a square here. And that right there is going to also be converted into 1 minus sine squared x. Okay. So we get 1 here, we get minus 2 sine squared x. If you expand this, you get 1 minus 2 sine 4x plus, 2x still for that one. This will become sine to the power of 4x. Expand, you get sine squared x minus sine to the power of 4x. Okay, so this one and this one will cancel out, right? That and that will cancel out. That'll become 2 sine squared x. So these two also cancel out, and you get a minus sine power of 4x. So let's put this at the front. Collect these two. Okay. And that's exactly what we have on the right side. Okay, so we've done the proof. And with regards to restriction, right? We have to make sure 1 minus sine squared x does not equal to 0. In other words, this does not equal to 0. In other words, sine of x does not equal to plus or minus 1. And also from here, right, we get this. We also have to make sure cosine of x, okay, does not equal to 0 as well. Okay. But fortunately, when cosine of x equals to 0 and when sine x equals to 1, it's actually the same thing. Okay, so if you look at the cosine curve, right, it's equal to 0 right here, which is 90 degrees. And for sine to equal to 1, it's also equal to, sine curve looks like this, at 90 degrees it's 1. So really we just have to omit all the values. Okay, this is the restriction. Sine of x cannot equal to plus or minus 1. And what we're going to get is essentially 90, right, and then 90 plus 360. So adding any multiples of 360, where n will belong to the set of integers then, as well as, right, negative 1 happens at minus 90. Of course, the graph repeats every 360. So again, you can multiply by any, you can add any multiple of 360.